In 2.5, we truly get into looking at what an actual proof will look like. 2.5 and 2.6 are your main sections of proofs here in Chapter 2. For 2.5, truly all we're going to look at is what a proof will look like, and we're going to do it in a very simple way. We're going to do it with algebra, just solving equations, right? We'll go over these properties again, we'll review these ideas, but essentially what you're looking at is going to be a problem like what you see here. Right? When we go to do these, the difference will be when you do a proof, they're going to tell you what your answer should be. And you need to get there in order to prove that that is true. So we have our equation. In a proof, we will always start with putting statements on the left and we're going to be putting our reasons on the right. Or our justifications, if you want to call them that. Right? That way, when we go to do this, we can number them and keep things kind of lined up. In a proof, you will always start with the given information. So we are given our equation here. 2 times x plus 3 minus 4 equals 16. Reason is that equation was given to us. Right? We'll always start by putting that given information in there. Now, there's multiple ways you can go through and solve an equation. That's why some people's proofs will look different than somebody else's. Right? For me, the first thing I'm going to do is get rid of my parentheses. So I'm going to take that 2 and multiply it into those parentheses. 2 times x is 2x. 2 times 3 is 6. Minus 4 equals 16. Now, the reason. What did we do? How did we get there? What allowed us to take that 2 and multiply it into those parentheses? And we'll review this idea, but that was known as your distributive property. It was a property we learned back in 5th or 6th grade. It's what allows you to take that 2 and multiply it by the x and by the 3. Now, we always say from there we're going to go through and we're going to clean up each side. Meaning we're going to take that positive 6 and negative 4 and combine them. I got 2x plus 2 equals 16. When you simplify each side, we did that by combining like terms. Now, if you want to call that simplifying, you can call it simplifying. I'd accept that. Technically, it's combining like terms. So I got 2x plus 2 equals 16. Well, we learned back in Algebra 1, you have to then subtract 2 from each side. Give me 2x equals 14. What did we do? That was what is known as your subtraction property of an equality. Some people have abbreviated this in previous years as POE, property of an equality. If you want to do that, you are more than welcome to. And then the last thing we do, we got to get rid of that times 2. So we divide both sides by 2. We get x equals 7, just like we were supposed to. Our reason, what did we do? How do we get rid of that 2? That was your division, what they call property of inequality. Right? And formally, that's what a proof is going to look like. Ultimately, there are 5 what they call properties of an equality. That's what we're going to start with here today. There's your addition property of an equality. That says you can add the same thing to both sides of an equation. So if 2 things are equal, if I add the same thing to each side, the result will also be equal. Your subtraction property says that if 2 things are equal to start, if I subtract the same thing from each side, then the result will also be equal. Multiplication works the same way. If two things are equal, then when I multiply by something on each side, the result will also be equal. One thing to note, you cannot multiply both sides of your equation by 0. That's why you see that C cannot equal 0. Division, same thing. You can divide by the same thing on both sides. Once again, as long as that thing is not 0. Now, your last property of inequality is known as your substitution property of inequality. This is going to be a big one going on, going forward this year, especially tomorrow especially when we get into 2.6, I should say. What your substitution property allows me to say is that if two things are equal, if A is equal to B, then A can be substituted in for B in any equation. It's kind of how you check your answer when you solved an equation. You would take that x equals 7 and you plug it back in. Right? That idea of plugging something in for something else is what is known as substitution. For those of you who follow along in your note packet, you will notice in example 1 they give us an equation. Right? Then there's an explanation in the middle. You can cross off this middle column. It only kind of confuses us as we go through these. We're only going to use that left-hand side and then the right-hand side, the reasons. So we're using the equation and we are using the reasons. All right, so we always start by writing each equation that is given to us. Now, our first step is that we are going to add x to each side. We always move all of our x's to one side or the other. So if you add x to the left-hand side, we have to add x to the right-hand side. That property is known as your addition. Property of inequality. Now, I put this in here because this is the only time I'm going to make you do this. Typically, when we add x over to the other side, most people just combine them right away. Technically, when you add them over, I got the 2x plus x, negative x plus x. When we combine those, I get 3x plus 3 equals 9. We talked how that is combining like terms. From now on, anytime you move it over, we can combine those two steps. When you tell me you're going to use that addition property of inequality, we are going to combine the terms when we take it over. Such as in this next step. Next step to solve our equation, what do we need to do? Well, we're going to subtract 3 from each side, giving us 3x equals 6. So the idea is we were going to subtract 3 from each side. What property is that? That is our subtraction. Oops, help if I can spell. That is our subtraction property of inequality. And when we use it, we're going to combine our terms when we take it over. We don't have to write out the minus 3, then combine terms. Right? Last thing to do then, how do I get rid of my 3? Well, we were going to divide both sides by 3. Giving us x to equal 2. That is our division. Property of inequality. Right? So the value of x is 2. That is what a formal proof is going to look like. Now, your other property we're going to look at here today is known as your distributive property. We used it in our opener. Distributive property says if I have some number out in front of my parenthesis, I can multiply that A into both parts to get A times B plus A times C, where A, B, and C are any type of real number. Right? Take a look at example 2 then. To solve the equation that's there, I want you to make a big 2-column proof for this. Right? This is what it's going to look like when you go to do this. You're going to have one of these on your Chapter 2 test. We put our statements on the left, our reasons on the right. And we always start with our equation. I'm going to number mine, so I make sure everything goes together. First step we need to distribute that -4. So we get -44x minus 8 equals 80. That was our distributive properties we just went over. Now we'll add 8 to each side. So add -44x equals 88. That was our addition property. And finally, we'll divide. We get x to equal -2. That is our division property of inequality. Right? That is what your proof is going to look like come your Chapter 2 test. Taking a look at example 3 then. In example 3, they give us it says Ricky Bobby travels 5 miles per hour slower than the speed limit S for 3.5 hours. The distance traveled D can be determined by the formula D equals 3.5 times that quantity of S minus 5. Solve for S. In your homework, you are going to see some problems like this that ask you to solve for X or solve for Y. To solve for a variable means to get that variable by itself. Meaning I need to solve this equation for S. So I got to get S by itself. Very first thing to do, we're going to take this 3.5 and we are going to distribute it in. So we write our original equation. That was given to us. Now we'll distribute it in. D equals, I get 3.5s minus 17.5. That was, as we said, our distributive property. Now to solve for S, I need to get rid of my minus 17.5. So we're going to add 17.5 to both sides. Since we added something to each side, that was our addition property of inequality. Finally, to solve for S, I need to get rid of my times 3.5. So we're going to divide both sides by 3.5. So we end up that D plus 17.5 needs to be divided by 3.5 to get my S. Since I divided on both sides, that was my division property of inequality. Now, there are 3 terms for us to go over here that are going to be very useful throughout the year. The first one is it kind of seems like a dumb one in and of itself. It is known as your reflexive property. And what your reflexive property is, it says something will equal itself. Now, it seems kind of dumb that 5 equals 5, 10 equals 10, because it kind of is. However, where it is useful is down the road in Chapter 4. We're going to talk about showing 2 triangles are congruent. To be congruent, 3 sides of one triangle, so this left-hand triangle, these 3 sides have to be congruent to the 3 sides of the right-hand triangle. Well, right now, AB has a single tick mark on it, and CB had a single tick mark on it. So they're congruent. I know that AD has a double tick mark on it. CD has a double tick mark on it. So there's one set of sides, two sets of sides. To get my third set of sides, I need to look at what's missing. Looking at that left-hand triangle, the side that's missing is BD. Looking at my right-hand triangle, the side that's missing just happens to be BD also. What the reflexive property allows me to do is say however big BD is on the left-hand triangle, maybe it's 5, maybe it's 6, maybe it's 10, then it is also that same size in the right-hand triangle. So no matter how big it is, it will have to be congruent to itself. That is what your reflexive property does. Your reflexive property says for any real number A, it would equal itself. A would equal A. It works for segments also, as we just talked about. For any segment AB, AB is equal to AB. And then it works for our angles too. Angle A will be congruent to angle A. Now your second property is known as your symmetric property. What your symmetric property does is it allows you to solve an equation, and if I solve the equation, get x equals 5, and you solve an equation, you get 5 to equal x. It allows us to both be right. And that's the idea behind your symmetric property. If A equals B, then B equals A. It works for your segments. If segment AB equals segment CD, then segment CD is equal to segment AB. And finally, it works for your angles. If angle A is equal to angle B, then angle B is equal to angle A. And then the last one is known as your transitive property. Your transitive property is what allows you to say that if A equals B and B equals C, there is one other set of values that must be equal. If A is equal to B and B is equal to C, then A is going to have to equal C. There is our other set. Now the difference is they talk about it in they talk about it in numbers, they talk about it in segments, they talk about it in angles. We just did it in numbers. If A equals B and B equals C, then A equals C. You can do it in segments. If AB is equal to CD and CD is equal to EF, then AB is equal to EF. And finally, you can do it with angles. If angle A is equal to angle B and angle B is equal to angle C, then angle A is equal to angle C. All right, taking a look at this proof. This proof, I'm going to tell you right now, you're going to have one almost identical to it on your test. So when you're studying, please look back at this proof. All right, they say AB is equal to something, and then that is going to be given to us. Well, there's two different ways they can give us information. They can flat out tell us and say, given this is true, or they can give us a picture and put markings in it. So looking at the picture that has the markings in it, AB has a single tick mark, so it must be equal to EF. That is given information to us. Likewise, BC is equal to, and in our case, that is DE. And that was also given to us. All right, now comes my first piece of advice when we're working with proofs. Always look to see, have you talked about that piece yet? If you have, how did it change? If you haven't, go look at the picture and why are you allowed to say this. So when we look, now we are talking about this segment AC. We have not talked about segment AC at all yet. So we go to our picture and try to figure out why we're going to be allowed to say that AC, which is this segment here, is equal to segment AB, which is this piece, plus the piece next to it, BC. And earlier this year, we talked about that exact idea. When you take two segments and add them together, and they're going to equal the whole thing. It had a property to it. It was known as your segment addition postulate. Right? Now we talk about DF. Well, once again, we haven't talked about DF yet. So let's go up to our picture. They're saying that DF, which is this segment here, is equal to segment, well, they don't tell us, but they tell us we're going to use segment addition. Well, what is DF going to be equal to? Well, that's DE plus EF. And as it says, that is going to be segment addition. So now we talk about segment DF. Have we talked about segment DF yet? Yeah, we just did. We talked about it right above. Well, then we got to see what changed. They took DE and it became BC. They took EF and it became AB. So we took something and replaced it with something else. It just so happens we said that those things we're replacing it with, EF got replaced with AB. DE got replaced with BC. There's a property we learned that says you are allowed to replace something with something else that was equal to it. We talked about it today. Another term for it, you're allowed to substitute something in for something that is equal to it. So we can go through and replace those with what is called substitution. We substituted our values in. Substitution was a property of inequality. So we put it there. Now, DF, we're still talking about DF. Now it has equals something. Well, what else was BC plus AB equal to? Because if I'm going to change something, it's got to be on the right-hand side. What else can we do? BC plus AB, we had said that was actually equal to AC. So we can replace it with AC. Once again, that is your substitution property. Now we got to look to see what changes. I still have my DF. Now all of a sudden I have this plus CD. I have a plus CD here. Well, if DF stayed on the left-hand side, then AC has to stay on the right-hand side. So what actually changed? You added CD to both sides. When you add something to each side of your equation, It is known as your addition property of inequality. Now, your last one, they say substitution. You can do substitution. You can do segment addition. Either way, all we're going to do is rewrite. What is CD plus, what is DF plus CD? Well, if you look at your segments, DF plus CD is CF. What is AC plus CD? That is AD. And whether you want to put substitution or segment addition here, depending on which one you see first, is completely up to you. I can tell you right now, this is the hardest proof that I'm going to make you do. All right? So keep that in mind going forward. Right? There's your homework, pages 108 to 109, numbers 3 to 26.